A warm welcome to all the viewers. In today's session, I'm going to discuss how to conduct multiple regression in SPSS in case you have the predictor or the independent variables which are categorical in nature. Usually, we conduct regression wherein the independent and the dependent variables are both measured on a continuous scale. But you might have come across certain analysis in articles, in dissertations, wherein you have spotted that the regression analysis was done with independent variables which were categorical in nature. How to do that? I will explain to you step by step how to do it in SPSS with the creation of dummy variables. What are dummy variables? Dummy variables basically represent each level or each category of that categorical independent variable, wherein the presence of the category is denoted by 1 and the absence of the category is denoted by 0. Let us start. How to interpret the results which we will be getting out of the regression model? The predicted difference between the two groups, the unstandardized coefficient or beta, represents the average difference in the dependent variable score between the two groups, and its p-value indicates whether this difference is statistically significant or not. The intercept or the constant is the conditional mean of the reference group. The intercept in a two-category model, say you have gender as a categorical variable, wherein 0 denotes male and 1 denotes female. In that case, you don't need to do dummy coding because it's already 0 and 1. So, the intercept will be the mean of the dependent variable for the group that is coded as 0. So, the reference category is male because that is coded as 0, and you have included female category in the regression model. So, the intercept value which you will be getting is the mean of the dependent variable for the male group. You will understand it better once I show you the practical, so stay tuned, keep watching. Next is the coefficient or slope. Say in case the value on slope you get is 2.5. That means the group coded as 1 is predicted to have a 2.5 units higher score on the dependent variable compared to the group coded as 0. Now let us go to SPSS and see how it's practically done. Herein I have the data sheet with 100 respondents. You can see case ID. It goes up to 100. Here is 100. And this is a fictitious data wherein I am trying to assess the effect or the relationship between these two independent variables and the dependent variable which is body weight. So the independent variables, both of them are categorical in nature. One is gender, having two categories, 0 denoted male and 1 denotes female. Food choice, there are 3 food choices. One is vegetarian, 2 is non-vegetarian, and 3 depicts vegetarian eating habit. So once I click on this thing, you can see what is coded as what. Body weight in kilograms. So I want to assess in this study that whether there is any impact of gender and food choice on the body weight. So for that purpose, as I told you, as there are two categories and they are well coded as 0 and 1, I don't need to dummy code gender. In case they were coded as 1 and 2, then yes, I do need to code it as 0 and 1, because dummy coding means that you are coding the variable's presence or absence only, which can be depicted by 1 and 0. I hope you are with me and you are getting the things. For food choice, there are 3 categories and we need to dummy code them, and there are 2 ways to dummy code it. How to do that? I go to transform. Now you see here, one is create dummy variables, which will automatically create those 3 categorical dummy variables for the food choice. Next is we manually do it. So first I'll show you how you do it manually, decode into different variables. And then I take food choice. Let me take it back. So I'll take the food choice and label it as vegetarian, which is the first category, like this. Label it as veg, change old and new values. So the old value is 1 and the new value is also 1. I add it, and here I check all other values. So all other values will be 0. How I did it? I'll just show it to you. I move it. All other values, the value will be 0. Except vegetarians, all others in this column will be coded as 0. So I do like this. I press continue and press OK. Now you see the dummy variable has been created. This vegetarian dummy variable has been created. Now similarly I'll do it for the other ones. So here I'll put the name as non-vegetarian. Take care that there shouldn't be any spacing between the name of the variable. That's why I put non_vegetarian. And in label I put capital N and veg, that depicts non-veg. Change old and new values. The old value for non-vegetarian category was 2, as I have coded it in spss, and the new value is 1. I put add. I first remove the previous one, and else value is 0. Press continue and OK. Now this one has been created. You see here non-vegetarian. This is vegetarian. Now the third category is left, which is vegetarian. Similarly, I go recode into different variables, and here I put vegetarian and label it as vegetarian. Change old and new values 3 and 1. Right? Add. Remove the previous one. Else is 0. Continue and OK. So now I have successfully created these 3 dummy variables, which I can take into my regression equation and take them as independent variables, and the dependent variable will be body weight. But you need to take care of one thing, that out of these 3, I just need to take the 2 of them, and leave one behind as a reference category with which I'll be comparing the results of these 2. So how to do that? Go to Analyze, Regression, Linear, and then I take non-veg and vegetarian into block 1 as independent variables. Now these both of them are dummy coded variables for the food choice, leaving behind vegetarian as a reference category with which I'll be comparing the results of non-vegetarian and vegetarian. So I leave one of the categories, that is vegetarian, as a reference group, and take independent the body weight. I press OK, and here are my results. Now you see R, which depicts the correlation, is 0.137. R square is 0.019, which is very weak. So that means both of these categories, vegetarian and non-vegetarian, do not contribute to the change in the value of the dependent variable extremely. Now whether this R square is significant or not, so this is insignificant. You see the value, P value in the ANOVA table is 0.399, which is well over 0.05. Had it been less than 0.05, then I would say yes, both of these categories in gender, both of these categories in food choice do have an effect on the dependent variable, do have an impact on the dependent variable, which is significant impact. In this case, it is insignificant. Had it been significant, I'll move ahead to the coefficients table, and in coefficients table, I see the results of my regression model. Now, This constant, which is the intercept 73.771, depicts the conditional mean of the reference category, which was vegetarians in this case. So reference category was vegetarians. So that means the mean body weight of the vegetarians is 73.77. The mean body weight of the non-vegetarians is, when you subtract minus 5.080 from 73.771, you get the mean body weight of non-vegetarian people. Vegetarians, when you subtract minus 1.668, that is the slope from the intercept 73.771, you get the mean body weight of the vegetarian people. So that is how you can compare the means of the three categories, taking one of them as a reference category. Now whether this is significant or not, we see the p-value. In case of non-vegetarian and vegetarians, in both of these cases we see the p-value is greater than 0.05, that means it is insignificant. And here it is 0.651, again it is insignificant. So both of the categories it is insignificant. So we will say that there is no significant effect of the food choices upon the body weight, although the mean score of vegetarians, non-vegetarians and vegetarians is different, but that is not significant, right? So that is how you interpret the coefficients table in regression. In the next video, I'll be showing you, in case you have one continuous variable also along with these dummy coded categories, then how to do it, how to do the mean centering of the continuous variable to get meaningful results out of the regression coefficients table. For now, let me show you the other way of dummy coding, that's going to transform and create dummy variables automatically. You can create, the system will automatically create it for you. Food choice, you take it and create dummy variables for, and root names you mention as food choice. So you mention it like this, food choice, and you click OK. So automatically you will be getting those three dummy variables which we previously created manually. Food choice 1, which depicts vegetarian, 2 is non-vegetarian, 3 is vegetarian. Now let us see, if we take gender also along with the food choice categories of non-vegetarian and vegetarian, then how to interpret that result. I again go to analyze, regression, linear, and here I put gender also. So remember that in gender we have 1 which depicts female and 0 is male. So we are taking male as the reference category like this, and we press OK. So now the three things enter: gender, vegetarian and non-vegetarian. Now R is 0.140, R square has improved, it is 0.020. Whether this is significant or not, whether these predictors have a significant effect upon the value of the dependent variable, in ANOVA table we say no, they are not significant, right? They are not significant in predicting the value of the dependent variable because the significant value is greater than 0.05. In case this was significant, in case they were significant in predicting the value of the dependent variable, that is the body weight, you see here dependent variable body weight, and predictors are gender, vegetarian and non-veg, then we go ahead to coefficients table and we interpret the results of the regression. But still I'll show you how to interpret these results. You see here constant, this is the intercept 74.289. So that is the mean, conditional mean of vegetarian people. That means the body weight mean score for the vegetarians is 74.289. The body weight mean score for non-vegetarians is minus 0.5.201. from 74.289. For vegetarians, if you subtract minus 1.632, that is the slope, from 74.289, you will get the mean score of the vegetarian people, the mean score of their body weight. Whether this mean score is significant, I mean to say whether this difference in the mean score of vegetarian compared with non-vegetarians, vegetarians compared with vegetarians, there is a difference in the mean score of the body weight, right? Whether this is significant or not, we see the p-value, and in both of these cases the p-value is greater than 0.05. That means it is insignificant. In case of vegetarians and non-vegetarians, it is 0.178, which is higher than 0.05. In case of vegetarians and vegetarians, it is 0.660 again, which is higher than 0.05. For gender, we see that we have taken female in this regression equation, which was depicted by 1, and is comparing it with the male category. We need to interpret it as the mean body weight for the female category is minus 0.882 from the mean body weight of the male category. So that means females have a lesser mean body weight as compared to males, and whether this is significant or not, again we see it is insignificant, right? So that is how you interpret the results. I hope the video was interesting and knowledgeable, and you will definitely share it with your friends and all those who are really interested to learn research. Stay tuned and keep watching for more. Thanks a lot.